Alright, we're going to continue with waves, and today what we're going to look at is what happens when waves interfere with each other. So we're going to look at what we call superposition. So what happens is when two waves connect with each other, the amplitude of the opposite waves, or the overlapping waves, basically is this algebraic sum of the amplitudes, which makes sense if you kind of think of it in just simple numbers. So if I have one wave that's an amplitude of 3 and it's going to connect with another wave of amplitude of 3, what happens when they join is they're technically just going to make a bigger amplitude of 6. So that's what we're going to look at today, is how some of that works. So there's two different types. The first is constructive interference, and that basically means exactly what I just showed you, was when our two amplitudes get larger, when the waves combine. So it can happen upwards like I drew it, or it could happen downwards. I could have two waves of 3, like two troughs, combining and making a bigger trough of 6. That's also constructive. So the individual waves combine to get larger. Destructive, it happens when one's a crest and one's a trough, and those connect. So if I gave you a wave of 3, and let's suppose the other one is 2, and they connect, the result would just be a wave of 1, right? Because we got 3 up and 2 down. So think of it as positive 3 and negative 2 gives you an amplitude of 1. So that's pretty simple math, and it works pretty good all the time. So here in this example, we got a wave of 2, amplitude of 2 and amplitude of 1. You can see as they start to connect, they get larger and larger. As they overlap, the one that's 1 and the one that's 2 join together to give us 3 total, which we just said. But what's interesting is after they separate, they go back to being exactly what they were before. So this one that was 1 to start with is still 1 going the opposite direction, and the 2 is still 2 going in its same direction. Destructive interference works the exact same way. So here we got 1 of 2 and 1 of 1. So when they combine, the 1 of 2 and the 1 of 1, so we have like a plus 2 and a negative 1. That would sum up to just positive 1. So it'll be a smaller wave of 1 upright. And after they join, they pass and keep on going in the same direction with the same original amplitudes as before. So here's a video you can see showing constructive and destructive. Go to the notes if you want to see that. And this also works if we deal with top view, and it's a little bit harder to visualize, but it works the same way. So remember, when we do top view, our circles are the waves. So you can see in this case where those two intersect, that's the crest of the red one and the crest of the blue one. So if these are both the exact same wavelength and amplitude and all that, where they would cross, that would give us a crest and a crest, so we would get our constructive interference there. And if we look at something that's in between, so if we went halfway in between the two reds and halfway in between the two blues, those would still be constructive, but that would then be our troughs, right? Two troughs together would make a bigger trough. And then anywhere where we see sort of the crest of one and the trough of the other, that would be our destructive interference. So that's where the waves would cancel out. So when you see these, it kind of looks confusing, but we actually get this repetition. So we have all these crests and troughs sort of overlapping in certain areas. So kind of we get these little diagonal line sort of shapes, and then we also get these diagonal lines of destructive interference, or where basically the waves cancel out. So if you actually look at a water wave of this, we get these what we call minimal lines. So where they overlap the most, we call it maximums. So the center one is the maximum, and then as we get further and further out, because we have less overlap, these next ones would be smaller and smaller. So we call them like the second maximum line or second nodal line, and so on, second, third, fourth. And anywhere where we get minimums, those would be not nodal lines, those would be where the antinodes are for the maximums, where we get constructive interference. Where we get the lines canceling out, where we have the crest of one and the trough of the other, that's going to create our node. So sometimes we call them nodal lines or just minimum lines, which means we have no waves. And then we get these sort of diagonal lines that show up. So we can see some videos here of different types. You can even see just in this one, you can sort of see these crests. So wherever these like little bumps are, those are our crests. And then wherever the dark shadows are, that's where we're getting our destructive. So you can kind of see these patterns of crests and troughs. The last thing we'll look at today is what we call a standing wave. And it's basically just a combination of resonance, reflection, and superposition. So and it's pretty easy to do, you don't need to do much, but once you create a wave pulse, so what happens is we send a wave down a rope or spring or something, and if it hits something solid, remember it's going to reflect upside down, and if we time it just right, we can get those frequencies to match perfectly, and our wave just sort of overlaps itself, basically makes a complete reverse of it. So we end up getting these nodes. So everywhere where the waves sort of cancel out, we have no movement or destructive interference. And everywhere we get these overlap of max and mins, we get these what we'd call our antinodes. And the wave just basically repeats back and forth over and over, and we get these, it looks like just bulges going up and down. That's what we call it, a standing wave. It looks like it's standing still, and it's just sort of pulsing up and down. So I just kind of sketched it out. So our antinodes, remember, is where the maximum or the constructive interference would be, and our nodes would be where the destructive interference is. And again, there's some videos here where we got water, standing waves, and we also have them on things like a spring or rope or whatever. So you can check those out, and that's it for interference and standing waves.